Hi and welcome back. We're going to start discussing proportions. And if you remember from our vocabulary a couple videos ago, a proportion is simply two equal rates or two equal ratios. So if we know the ratio of a number to 3 is the same as the ratio of 16 to 6, we can find that number. The first thing you need to do is set up that proportion, making sure you keep the related numbers in the correct position. So here there are four parts to our proportion, and we're given three of them and asked to find the fourth. And so this says a number to 3. So some number, you can pick any variable you want, to 3 is the same as 16 is to 6. So we set up our ratios, write them in the exact order. Next, solving these, we're going to cross multiply. So I have, what that means is you take the numerator of the first fraction and you multiply it by the denominator of the second. So n times 6 is 6n. And then we take the denominator of the first fraction and we multiply it by the numerator. 3 times 16 is 48. Now in our last step we simply solve for the variable. So we had 6n equals 48. Knowing that, we have to undo this multiplication. We're going to divide both sides by 6. So I have 6n equals 48. In order to isolate my variable, I divide both sides by that coefficient. My 6's cancel, and I'm left with n equals 48 divided by 6 is 8. So my missing number is 8. The next thing and the last step is to check your answer. And we can do that just by using the cross products and going back to our original setup. So I have 8 is to 3 as 16 is to 6. Now I take the cross products, and if I've not made an error, they should be equal. 3 times 16 should equal 8 times 6. This is 48 equals 48. My answer is correct. So my missing value is 8. N equals 8. So I'm going to do one more, and then I'm going to ask you to do one. On a certain blueprint, the measure of 25 feet is represented by 2 inches. Now, is that a ratio or a rate, and why? Well, that's going to be a rate because I have two different units, feet to inches. So my first step is to set that up. I'm going to write 25 feet to 2 inches. Same as. The actual distance between 2 points are 5 inches apart on the blueprint. The key to doing proportions is to keep the same units in the numerator and the same units in the denominator. So that 5 inches needs to go in the denominator, and I'm looking for how many feet that's going to be in actuality. So according to my steps, the next thing I do is cross multiply. So I have 25 times 5, which is 125, equals 2x. Isolating that x, I need to get rid of the 2. They're multiplied together, so the opposite operation is division. So I'm going to divide both sides by 2, canceling out. So I have x equals, and dividing 125 by 2, I'm going to get 62.5 feet is the actual distance when it's 5 inches on the blueprint. So let's check our answer. I'm going to substitute that 62.5 into my original equation. I'm going to do that in red. And here I'm going to have 25 feet is to 2 inches as 62.5 feet is to 5 inches. Cross multiply, and 25 times 5 should be equal to 2 times 62.5, and I have 125 equals 125. My answer is correct. The actual distance is 62.5 feet. Please pause the video at this point and begin example 10. All right, let's see how you did. Question 10 says, before construction can begin, a tree needs to be cut down. The tree specialist needs to know the height of the tree in order to determine which way the tree may fall to avoid damage to an already existing structure. You use a 6-foot pole and it casts a 4-foot shadow. If the tree casts 35-foot shadow, how tall is the tree? So we have 6 feet is to 4 feet, and I'm just going to write shadow as how tall is the tree. That's what we're trying to figure out. If it casts a 35-foot shadow. Here it was a little bit more tricky. We had to keep shadows in the denominators and the actual height in the numerators. Doing this, we set up our proportion, and now we're going to cross multiply, and I have 6 times 35 is 210 equals 4x. Dividing both sides by 4 to isolate my variable. X equals 52.5 feet. Double checking to make sure my answer is accurate, I'm going to substitute 52.5 in for x. And here I have 6 is to 4 as 52.5 is to 35. Cross multiplying to check. 4 times 52.5 should equal 6 times 35. And 6 times 35 is 210, and so is 52.5 times 4. So the actual height of my tree is 52.5 feet. That concludes this video on proportions. Please take a few minutes, go and do the online self-check, 5 quick problems to make sure you thoroughly understand ratios, rates, and proportions. If you have any questions, please bring them to class with you next time we meet, and we'll do some more examples there. Make sure you print out your results so you can turn those in for credit on that self-check. Thanks, and we'll see you in the next video, which is going to be direct and inverse variation.